Hello, my name is Andy Tyrrell and I'm head of the Department of Electronic Engineering at the University of York. And what I want to do in the next few slides is give you a bit of an overview of the university and of the Department of Electronic Engineering, and say a little bit about our facilities and the modules and the courses that we provide if you come here to York to do a degree. So just a little bit about the city to start with, just in case you don't know too much about York. So it's a very old city. It was founded in 71 AD by the Romans, and it has a population of around about 200,000. So not such a big city. And here are a few pictures just to give you an idea of what the city looks like, including what I would consider as the best railway museum in the UK, maybe the world. It's a very nice place to come to. Okay, a little bit about a few shots of the university. So here are a few pictures of the campus. So York's a campus-based university. And the picture in the middle here, which shows some of the lake, also shows our building. So most of the activities, not all of them, but many of the activities go on in this building, which we share with the physics department right next to the lake on campus. So let me tell you a little bit about the structure of departments at York. So within the university, there are 3 faculties. So the Faculty of Social Sciences, Faculty of Arts and Humanities, and Faculty of Sciences. So quite a typical overall structuring of faculties within across the university. And within the Science Faculty, which is the one that we're in, there are 10 departments. So these include some of the ones that you might expect in the Science Faculty, such as Physics and Computer Science and Biology, Chemistry. It also includes Environment and Geography, Health Sciences, Maths and Psychology, for example. And this is where the Electronic Engineering Department fits within the structure of the university. So engineering, we're passionate about engineering, and for me, engineering is all about building things, about creating things. And actually, if you think about how many things that you've used today, you used yesterday, that you're going to use tomorrow, pretty much everything was designed and built by engineers. So from very small things, so the circuits and and everything that's inside your mobile phone, to things like aeroplanes, to things like cars, to things like trains. And all of these things are designed by engineers. And for me, what an engineer does, it takes a problem, an opportunity, and applies creativity and applies technology to the problem to solve these problems, to come up with innovative designs and create the future. So a really obvious example of this is mobile phones, smartphones. So 10, 12 years ago, smartphones didn't really exist. And through the development of that, through engineering and the creative side of engineering, we've now got something which I think most of us would find quite difficult in the world to carry on without using smartphones. And I think the interesting thing there is, for many people, is the idea of creativity. So people think of engineers as being quite mathematically based, which it is, but actually there's lots of room for creativity. There's lots of room in the design domain of engineering to apply creativity to lots of areas. So let me just talk a little bit about some of the facilities in the department. So we as you might imagine, we have a standard kind of electronics and electrical engineering laboratories with standard test equipment that's shown here. We have a new facility which is related to engineering, and this shows our materials and mechanics lab that was opened this year. We have clean room facilities for doing integrated circuits and nanotechnology type activity. We have 2 or 3 studios and an anechoic chamber, which is mainly used from our audio and music technology side of things, but actually is bookable for other students in the department. We have a robotics lab, so more used for research, but we've started last year a new program in robotic engineering. So we've got a robot lab or labs which will be used for those programs. As you might imagine, we've got quite a lot of computing labs, and many of them are dedicated to the department, because actually we tend to connect things to computers, devices and boards to computers for students to use during their labs and projects. And these days, 3D printing is actually a really common resource for our students to use. So when they're doing projects and other small activities, they want to prototype, if you like, an enclosure as well as the electronic thing, and 3D printing resources allow them to do that really rather easily. So let me talk briefly about the philosophy behind our programs. So of course, it's an engineering program. We have to start off with engineering fundamentals. So maths and physics do come into it, that they form the foundations for any engineering program. But we're also interested in what young engineers, or what future young engineers are interested in. So we take input from that, both from our current students and from students that have recently graduated and are working in industry. Talking of industry, we obviously also need to know what industry. We want to produce graduates that can get jobs in the appropriate industries. So we have a lot of input from our industrial partners, which I'll talk about in a few slides' time. And of course, we want to input our research into our teaching. So we want to show students the latest things that are going on, the latest research that we're doing. So all of those things combined end up allowing us to produce our undergraduate programs. And I've divided them into 3 categories here. I'm sure you've seen on the web that there are a lot of programs within each of those. But so the engineering programs, so I've called it Engineering Plus Plus, because there's things like robotic engineering and medical engineering that fit within those programs. There's our electronic programs, so there's electronic engineering, but there's also programs like electronic and computer engineering, electronic and communications engineering, which fit under those. And then there's electronic and electrical engineering, where we're combining both the fields of electronics and electrical in a program. So all of those different types of programs are all built on this philosophy. And what we're trying to do, what we aim to do, is take interested school leavers, combine that with our programs over 3 or 4 or 5 years to produce graduates that are easily employable either in industry or in research careers. And we feel that we do that rather well. What sort of careers might the programs lead to? Well, here's a few examples of some companies that I suspect you've heard of many of these companies in the past. So some of our students go into research and development, so either into universities or into companies that focus on research. Many go into what I would call mainstream engineering, so companies like BAE Systems, Jaguar Land Rover, Rolls-Royce, Ford, those types of mainstream engineering companies. We do a lot of programming on our courses, which means our students are really well suited for working in software industry and doing programming. Obviously, electronic engineering companies take many of our students. Healthcare, and there's lots of final year options, and with our new medical engineering program, where students can move into the healthcare industry, financial and other services, kind of generic services which just want to employ bright people. And then music and media. So we have a number of programs on audio and music technology. And so people like Google, BBC, Sony actually take our graduates often from those programs, and with a background that suits very well for those sorts of industries. Okay, I talked a little bit about industry before, so let me just briefly talk about our industrial input. So we have many guest lecturers coming from industry to give talks on many of our modules, and there's just a subset of them here across all stages of our program, from the first year to the 4th year. We have many students that go on placement, so typically for the BN students at the end of year 2 and for the MN students at the end of year 3, they can spend 1 year in industry, and we have a member of academic staff that looks after our students that are looking for placements and while they're on placements. And some of our final year projects are actually suggested by industrial partners, sometimes actually from a placement. So a student might go on placement for a year, come back, moving into the final year and saying, actually, I want to carry on what I did there and turn this into a final year project. And in addition to all of those, we also have an external advisory board, which is made up of 10 or or 12 industrial partners who come along to York twice a year to give us advice on our programs, to look at final year student projects and things like that, to give advice on that. So a lot of industrial input, both students going out and industry coming in to help us. And York is a teaching-led university, a research-led university, where we try to feed in as much of our research as we can into the teaching. It obviously mostly happens in years 3 and some year 4 modules, to the more advanced modules. Most of our projects, I would say, are based on some point. Final year projects are based at some point with our research that goes on. And we have a number of spin-out companies, so that there's 5 here listed. And many of these take on graduates to work with them, maybe on internships and things like that during their time at York. So projects we think are important. For me, engineering is all about building stuff. It's all about making things. So all of our programs are very much focused on many projects that the students undertake through the 3 or 4 years, depending if they're on the BEng or MEng. So in the first 2 years, all the students do group projects, and it gets more difficult, as you might imagine, between year 1 and year 2, more demanding for students to do that. Typically the groups might be of size 5 or 6, to try to mimic in some way how projects work in industry, to get people working together, and they can build much bigger projects. They can achieve much bigger things by doing this. And there are many examples so in fact, example in the first year might be building a small medical device to deal with things. In the second year, it might be building an environmental sensing system, for example, but they vary from year to year. Then in stage 3, year 3, if you're on the MEng, so a 4-year program, then there's a very large software group project. And then in the BEng, you do a solo project, which typically is led by one of the research groups, or maybe academics working in research groups. And then in stage 4, if you're on the MEng, it's an 80 credit, so a very large solo project, again, typically based in one of the research groups. So for us, the input, I think it's really important that students get project work in all years and learn how to work in groups. So learn how to work together on big tasks and big projects. So finally, these are a few shots of work, research, mostly research work that's going on at York to do with robotics and communication systems underwater and building chips. And so I think it's important that you think about your future as you're going through the stage of deciding which universities to go to, and make sure that you consider how you might engineer a better one for yourselves. And we look forward maybe to seeing you in York at some point in the future. Okay, thank you very much for your attention.